Good evening. My name is Patrick Curran, and this is Evaluation of Non-Destructive Inspection Methods of our class AMNT 322 on the 5th of April 2026. The objective of this briefing is to assess 7 NDI methods based on their operational effectiveness and financial feasibility. Each method will be evaluated in terms of its advantages, limitations, and cost implications. For a scheduled maintenance program to be successful, it must strike a balance between practicality, reliability, and affordability. This analysis will help identify which methods should be prioritized for routine use versus specialized application. Firstly, we have the visual inspection, and the visual inspection is the most fundamental and widely used NDI method. It involves direct observation of a component, often enhanced with tools such as magnifying glasses or borescopes. Its primary advantage lies in extremely low cost and ease of implementation, as it requires minimal equipment and training. However, its effectiveness is limited to surface level defects, and the accuracy heavily depends on the inspector's experience and attention to detail. While it cannot replace more advanced methods, visual inspection remains an essential first step in any maintenance program. Ultrasonic testing uses high-frequency sound waves to detect internal flaws within materials. This method is highly valued for its ability to identify subsurface defects with a high degree of accuracy. It is widely used in aviation and manufacturing due to its reliability. However, ultrasonic testing requires skilled technicians and proper surface preparation to ensure accurate readings. The equipment and training costs are moderate, but the return on the investment is significant due to its effectiveness. As a result, ultrasonic testing is considered a core method in many maintenance programs. Attached, I have the amplitude of the ultrasonic frequencies, that is a time dilation that shows large area corrosion, small area corrosion, or no corrosion. As an example, radiographic testing involves the use of X-rays or gamma rays to create images of a component's internal structure. This method provides a permanent record which is useful for documentation and further analysis. It is highly effective in detecting internal defects that may not be visible through any other methods. However, the use of radiation introduces significant safety concerns and requires strict regulatory compliance. Additionally, the equipment and operational costs are very high, making it less practical for routine inspections. Radiographic testing is best reserved for critical inspections where detailed internal imaging is necessary. Magnetic particle testing is used to detect surface and near-surface defects in ferromagnetic materials. This process involves applying a magnetic field and observing the accumulation of particles at defects locations. This method is relatively quick and cost-effective, making it suitable for routine inspections and only on certain applicable materials, ferromagnetic. However, it is limited to ferromagnetic materials and cannot detect deeper internal flaws. Despite its limitations, magnetic particle testing is a valuable tool when used in the appropriate context. A very familiar one in the aviation industry is liquid penetrant testing. Liquid penetrant testing is a simple and inexpensive method used to identify surface breaking defects. It works by applying a liquid penetrant that seeps into cracks, making them visible under proper lighting conditions. This method is highly sensitive to small surface defects and requires minimal equipment. However, again, it is limited to surface inspections only and requires thorough cleaning before and after the application. But due to its low cost and ease of use, the penetrant testing is widely implemented in routine maintenance programs. The eddy current test. Attached, I have a diagram of how exactly that works using magnetic fields, currents, and eddy currents on conductive metals. The eddy current testing uses electromagnetic induction to detect flaws in conductive materials. It is particularly effective for identifying cracks and corrosion, material thickness variations, but one of the key advantages is that it requires minimal surface preparation and provides immediate results. However, again, like many others, the depth of its penetration is limited, and it requires calibration and trained personnel. The cost of this is moderate, making it a practical choice for applications such as aircraft skin inspections and structural assessments. Thermographic testing, also known as infrared thermography, detects temperature variations on the surface of a material to identify subsurface defects. This method is a non-contact and allows for rapid inspection of large areas, making it useful in certain advanced applications. However, the equipment is expensive, and interpreting the results requires specialized training. Due to these factors, thermography is typically used for specialized diagnostics rather than routine maintenance. My conclusion of this is that no single non-destructive inspection method is sufficient to meet all of the inspection requirements. The most practical and cost-effective methods for routine use include visual inspection, liquid penetrant testing, and ultrasonic testing. More advanced methods, such as radiography, thermographic testing, they should be reserved for specialized applications where the higher costs are justified. Ultimately, an effective maintenance program should incorporate a combination of NDI methods to ensure reliability while maintaining cost efficiency. Investing in trained personnel and standardized procedures is essential to maxing out the effectiveness of these inspection techniques. And that is my presentation. Please see the works that I cited. I used 2 books, Non-Destructive Testing and Non-Destructive Testing Handbook, Volume 9 from the American Society for Non-Destructive Testing, as well as I used a manual publication from the Tinker Air Force Base, and that showed non-destructive inspection methods, the basic theory, and how the military provides it. So I did the civilian sector and the military sector. And that is my presentation. Thank you.